paper. So let's start with the question. So the question says a person lifts a crate vertically upwards at constant velocity through a distance h, and this person does work x on the crate in time t. Paper. So now lifts the same crate vertically upwards at constant velocity, the same distance, but they now take twice the amount of time. They now lift this in time equal to 2t. And they want us to find the work done by the person on the crate now. So the first equation that we're going to talk about is work done. We know that work done is equal to F delta x. This is the force that is being applied, and this is the distance that your object travels. We then are going to look at Newton's second law. So Newton's second law is F net equal to mass times acceleration. So going back to the question, in both instances, the object is moved at constant velocity. So what does constant velocity mean? It means the velocity is not changing. And if the velocity is not changing, your acceleration is equal to 0. Force that is being applied, and this is the distance that your object travels. We then are going, F net is equal to mass times acceleration, but acceleration is 0. So that means that F net is mass times 0, which is 0. Now, what does F net being equal to 0 mean for us? It means that your forces are balanced. It does not mean that your forces are equal to 0. It means that they are balanced. What does that mean? In this case, we are looking at vertical motion. So it simply means that the upward forces is equal to the downward forces. And that is what we're going to use to understand this. So let's go down here. So if the upward forces are equal to the downward forces, let's understand what is happening to this object. So the mass is the same. So the mass is same. The distance that the object travels is also the same. So let's assume you have a block of mass m. In the vertical direction, there's two forces we would consider. There's a weight, which is mass times gravity. And then there's the force that is being lifted, or that is being used to lift the block, which is the applied force. We'll just call that FA for now. So the fact that the mass is the same, and the fact that the forces, the F net is equal to 0, meaning that the upward force is equal to the downward force, this just tells us that the applied force, I'm going to put this down in words, the applied force in both cases are the same. So just want to make sure you understand why I'm saying this. If the upward forces is equal to downward forces, it means that FA is equal to mg. G is constant. And your mass is also constant. It's not the same. Sorry, it is the same for both examples. So that would mean that FA is the same in both cases. So the applied force in both cases are the same. Going back to the first equation we put down, we said that work done is equal to F delta x. This F here is the applied force that we are looking at. We're looking at the work done to lift the object. So if the applied force is the same and the distance traveled is also the same, it means that the work that is being done is also the same in both cases. So going back to the question, they told us that the work done in the first instance is x. So that means that the work done in the second instance is also x. F net is equal to mass times acceleration, but acceleration is 0. So that means that F net is mass times 0, which is 0. Now, what does F net being equal to 0 mean for us? It means that your forces are balanced. It does not mean that your forces are equal to 0. It means that they are balanced. What does that mean? In this case, we are looking at vertical motion. So it simply means that the upward forces